Today's topic is exponential function. Okay, we're going to identify the growth and decay according to the formula. Okay, let's start. So the formula for exponential function is y. All right, I don't know. Y. What's happening? Y equals. Let's do it again. Okay. Y equals a times b raised to x, or y equals a. Sometimes you're going to see a parenthesis b raised to x. Okay. So now let's identify these variables here. So a is your initial value when the problem is a word problem. Usually the first value they're going to be give on the problem will be the initial value. That will be the a. While on the graph, a is your y-intercept. So what I meant by that is if this is your graph, you're going to see either increasing, and when it intersect y y axis, it is your y-intercept or the a, or decreasing or decreasing. It looks like this. Okay, so this is your a. Now we identified the a. Now what is the b? B is your rate. B is a rate, no? So let's review first. What's the rate, no? Sometimes they're gonna give you, let's say, 5%. The first thing you need to do is convert this to decimal. So I'm going to move that two places, one, two. So 5% is 0.05. Let's say 50%. I'm going to move the decimal, one, two. So 50% is zero point 0.5. Let's say 500%. I'm going to move the decimal, one, two. 500% is 5. Okay, but by the way, what's this rate? No, the rate sometimes will predict if your function is growth or decay. Okay, here we go. If the rate or the b is greater than 1, this is growth. Okay, if the b is less than 1, this is decay. All right. Now, later on, I'll go through in-depth information about the growth and decay. But for now, let's finalize the last letter. The last variable is x. X is the input. Usually, this is time. Sometimes they're going to use the word yearly or annually. It means every year. Sometimes we're going to use month, weeks, and so on. Okay. Now we identify the value of the variables. Finally, of course, y, I'm going to write it here. Y is your output. Okay, output, it means after we use all the variable, including the input, the final value will be the output. Okay, all right. Let's go on to the next. Let's go to in-depth information. So I mentioned earlier that there are growth and decay. Let's start with the growth. The growth will have a formula which is A times 1 plus the rate raised to x. How do we know if it's a growth? I mentioned earlier, if your B is greater than 1. Now, basically, if you add a rate on 1, it's going to be greater than 1. But if it's a word problem, you will hear the words or vocabulary like increasing, yearly, monthly, and interest rate. Okay. And oh, I pressed something. And interest rate. So this means you have a growth. Okay. So now this is in word problem. Okay. Like I mentioned earlier, if they give you a percent, make sure percent convert to decimal. Okay, let's start. Let's continue. The graph of a growth will be looks like this, from the asymptote going up, and this part here will be your A, and the graph is increasing on the L axis. L axis. I'll use the word L axis on the L. Okay. Now let's look at decay. Let's change color here. Let's change color. So on decay, I'll use green. Mm-mm. Okay. Decay, okay, the formula is y equals a 1 minus, again, minus the rate raised to x. So as I mentioned earlier, if we're subtracting a rate from 1, the value will be less than 1. So what does it mean? It can be uh, a fraction or a decimal, let's say 0.75, or 3 quarters, as long as it's less than 1. Sometimes that's how it works. Okay. Now the words or vocabulary that they're going to use for decay is are decreasing, diminish, and reduce. Okay, here we go. Now the graph of a decay will be looks like this. It's going down on the L axis or L axis. Okay, so this is your A. Okay, this is how you identify if the problem is growth and decay. Okay, Later on the next video, I will discuss or help you to solve problems for growth and decay. Thank you. Of the topic growth and decay. Here we go. So, the first part here is classify each function as exponential growth or exponential decay. As we do, let's do recap, okay? Recap. I mentioned in the previous video that the formula is y equals ab raised to x. But when the b is greater than 1, we're going to like the answer will be growth. And if b is less than 1 or smaller than 1, the answer will be decay. Okay, now we're going to identify these first three questions. Okay, the first one is y equals 8 times 1/4 raised to x. So remember, this is my a, my y-intercept, and this is my b. So my b is less than 1. 1/4 is smaller than 1. So this problem here, it's a decay. Okay, now question number 2. Looks like there's no a, but this is imaginary 1. So your a is imaginary 1. But your b is greater than 1. Well, 7 over 2 is like 3 point something, okay? Okay? 3.5, no? 7 over 2. So it means this is growth. Number 3, same thing. My A is 1/3. Okay, the y-intercept is 1/3, or initial value is 1/3, but my B is greater than 1, which is 5. So B equals to 5. This is also a growth. So that's how you identify, just looking at the formula, if the exponential equation is a growth or decay. Now, question number 7. This time, they're going to ask you to graph, okay? Like we did in the first three questions, we need to identify if this is growth or decay. The A is 1/2. So what does it mean? It means this graph will intersect on half, somewhere here. So that's A, okay? A is 1/2. Now, let's look at B. The B is greater than 1 because B equals to 4. So it means that this graph is from left going up like this, okay? So increasing. So this means increasing or growth. So increasing on the L axis, okay? L axis, they call it L axis. Again, this is a growth, okay? Now let's look at question number 8. Question number 8, it says y equals to 2 times 1/3 raised to x. So my A is equals to 2. My B is smaller than 1 or less than 1. It's just 1/3. So B is equals to 1/3. So let's graph this. So my A is on 2. That's my A. A equals to 2. But since this is smaller than 1, so this is a decay. Okay, so the graph is going down. Okay, going down. Undo. Okay, let me erase this. So the graph is going down. Okay, so that's the graph of decay. Okay, let's go on to the next few questions. Question that might ask during the test. Let's look at this word problem. Okay. Okay. First is annual sales for the fast food restaurant are 650,000 and are increasing. That's the word that you're going to identify. Increasing at the rate of 4%. 4%, that's 0.04. per year. Use exponential function to find the value of annual sales in 7 years. Okay, this time they give us the value of x. Formula y equals a times b raised to x. Okay, my a is 650,000. The b, well, this is increasing. Okay, so I'm going to use the word, the formula 1 plus the rate, which is 0.04. So my b is 1.04. And the value of x is 7 years. So I'm going to rewrite this again. Y equals 650,000, parenthesis, 1.04 raised to 7. They're looking for the value when it's 7 years. So I'm going to type it in my calculator. I'm going to use Desmos. So this is 650,000. 650,000, okay, raised to times 1.04 raised to 7 years. So in 7 years, the value will be 855,355 point, I'll put 66. So that's the value, the value of the annual sales after 7 years. Okay, last question. The population of a town is 2,500 and is decreasing at the rate of 3.5 per year. Use an exponential function to find the population of the town in 5 years. All right, here we go. Well, my percent is 3.5, so I'm going to move that twice, so 0.035. Okay, let's try it again. I'm going to write my equation: a times b raised to x, where a, well, the initial value is 250,000 population, and they said it's decreasing. Okay, so my b, this time I'm going to use 1 minus 0.035. Okay, so here we go. So 1 minus 0.035 is 0.965. Okay, so 0.965. Okay, here we go. And then my x is 5 years. Let's rewrite the formula. Y equals 2,500, 0.965 raised to 5. So now I'm going to compute the value after 5 years, okay? So I'm going to type it in my Desmos, parenthesis, 0.965, close parenthesis, raised to 5. So in 5 years, the population will decrease to 2,092.07. So if this is a real life example, real life application, so your value will be 2092. Thank you for listening.